next up, we're going to welcome the team from Germany. They worked on a project called FreeSpeak, and they're going to be sharing more about, essentially, it's a project that helps people with their public speaking skills and is using machine learning. So it's super cool. And I wish I had used this before I spoke to all of you today to make sure that my body language is working out. So I'm really excited to see this project. And we also have special guest Lawrence from the TensorFlow team, who's going to be asking them a couple questions. So let's take a look at the project.
Giving a good presentation is really hard. Now imagine this. You are currently in a selection interview for a really big company. You have 2 minutes in which you have to present yourself. 2 minutes that will decide if you will get approved to the company of your dreams or rejected. One presentation that can have a big impact in the future. When we looked around at our local university, we noticed something. Many tutors or people giving presentations have one thing in common. They know a lot and can provide lots of knowledge, but oftentimes the audience just falls asleep. We have asked experts in the field of rhetoric and communication, and what we have learned is that many people focus on improving their content, but they forget one of the most important aspects of presentation: body language and emotions. Now, a presentation without proper body language and emotions is like food without proper seasoning. The problem is that our current education system just doesn't teach us such important soft skills. Getting professional soft skill training is really rare to find and really expensive. We wanted to change this.
We created a software that records the presentation, analyzes it, and gives personalized individual feedback and tips to improve your presentation. Using Google Speech API and Google Cloud Sentiment Analysis, we can analyze data about the talking speed, the recognized emotions in your voice, or the content of your speech. With TensorFlow, we can use machine learning to analyze the body language and facial and emotional expressions in the video. In the future, we could add individual training exercises or analyze more aspects of a good presentation. And with today's technical advancements, the possibilities are endless.
Hello. Hi, Team FreeSpeak. Dialing in all the way
Hi.
from Germany. Hi, how are you doing?
Great.
Great.
Thank you.
Good.
Thank you.
And we're joined by Lawrence as well from Google. Lawrence, good to see you. How are you doing?
Good to see you too. I'm doing great. I'm really glad that I'm towards the end of the day. So it's like I've gotten to see all these projects all day, and they're just absolutely amazing. It's so inspirational to see.
Definitely. Yeah, I'm so inspired. So yeah, we'd love for you to introduce yourself. And I know you took a look at the project, so I'd love to hear more.
Yeah, I'm Lawrence. I work on the Google Brain, Google Research into Machine Intelligence team. I lead AI advocacy there. So I work very closely with TensorFlow and with researchers in TensorFlow and like what people are doing around the world with TensorFlow. And so I'm just really delighted to be here to see a couple of these projects that have used our technology to just build amazing stuff. I don't have a cool sweater behind me like Todd though, so I'm just going to have like a boring background.
That's fine. You have your jacket, so all good.
Yeah, I got my jacket, so yeah.
Nice. Great. So I'll pass it over to you.
Yeah, so Team FreeSpeak, I do a lot of presentations myself, and I wished I'd had something like this when I was learning how to do them. So just congratulations on the amazing work. And I have so many questions that I'd like to ask, but we've only got time for a couple. So I'm going to just dive right in. And one of the things that really impressed me about this project was the fact that you use multiple machine learning models. Right? You have the object detection, you have emotional sentiment, you have text sentiment. How was it to try and orchestrate all of these together to really build a solution?
So, yeah, I would like to answer that question. Yeah, you're right. We have many different models. And with models, I mean that we have many different features. And like you already mentioned, our features are, for example, hand detection or facial expression recognition, voice emotion recognition, and so on. In each of our features, use a different model. And of course, tying all of them up in one single program was a really big challenge for us, even the hardest one during our project. And to tie everything up into one program, we used multi-threading. And we have chosen multi-threading because some of our features, such as hand detection or face expression recognition or speaking speed measurement and so on, had to run in parallel. And of course, multi-threading is like the best choice. But multi-threading can get very complicated, especially if there are many features that have to work in parallel. So our program sometimes crashed. And we are sure that it crashed because of multi-threading, because we tested each of our features in many different ways, independently from one another. And we also adjusted the code in our program, and those features were working perfectly. Also, for some of our features, we used pre-trained models such as text sentiment analysis or speech recognition from Google Cloud. So of course, those features were working without any problems. So to sum up, our features are working without any problems or major mistakes. So the biggest challenge was tying them up, like I already said. But even if multi-threading was really hard for us, we had a great opportunity to learn more about it, and also machine learning. And we had a lot of fun with it, and we got nice experience. So in the end, we could manage to fix all the issues by trying out some workarounds and also simplifying our program.
Well, I'm really glad you had fun with it. I'm happy to hear that part. And to me, I really think the future of great AI apps are where you have specialized models and you're building something that orchestrates them together instead of trying to build a great big unified model. And that was something that really stood out in your project, how you did that. So that was really, really cool. But one more question I have on it is that one of the things that you're doing is like you're measuring people's hand movements and sentiment in their face. And how did that work from like a training perspective with like different people's shapes and sizes? And, just people look different to each other, right? How was it for training models?
Yes, that's a great question. And so for our machine learning models, we used publicly available open source datasets because in our opinion, one of the hardest parts of machine learning is like getting good data, because like good data is really a key to high accuracy of a model. And because the time of this challenge was limited, we wanted the best possible data in the shortest amount of time. And this is why we looked for already existing open source projects and the datasets which they used. So the benefit of this approach was that we found large datasets that already contained a huge variety of hands, faces, or different voices of many people. So for example, one dataset which we used was the RevTest dataset for voice emotion recognition, and it already contained over 7,000 audio files spoken by, I think, 24 different voice actors that mimic different emotions. And another example is the Oxford datasets, which is used for hand detection, and it even contains over 10,000 different hand instances, and they already had their data separated into training and validation sets. So this is why we didn't have to tackle the problem of different shapes and sizes that much, because we already found large datasets with a huge variety of instances. But still, of course, there were some problems that we had to deal with. For example, positioning the camera or the lighting can indeed have an impact on the accuracy of our model, but this is something that we're still working on, and this is why we are also trying to make our models more robust.
Excellent, excellent work. Erica, I could talk about this project all day, but I know we have to take questions from other folks, so maybe we can take one from the YouTube now.
Sounds good. Yeah, let's see if there's a question from the live chat. Did you have any performance issues?
I would say yes, because starting up the program could take like 1 minute, because like everything should be prepared, every model should be prepared and so on. So yeah, that was like also one of our biggest issues to deal with.
Yes, and another problem is maybe about going like public on mobile devices, for example, because it does indeed take a lot of computing power. So we might have to host them on different servers. But currently, when we are running them on our local computers, there's also, for example, the difference between running it on CPU or GPU. And surprisingly, for example, running on GPU even makes the startup time or the program a little bit slower, because it has to allocate the resources, and it takes quite a few minutes to load up.
So it's different on our computers. Like the project on my computer starts much faster than, for example, the project on Imo's computer.
We know who has the nice computer.
Great. Well, thank you
Very,
so
very
much
cool.
for sharing with us. We do have to wrap up, unfortunately. I also want to hear more. We could talk about this project for a long time, but great work on this. Thank you so much for joining us. And also thank you to Lawrence for being here with us, and he'll be sticking around for the next project, but great work, FreeSpeak team. Awesome.
Thank you so much. Amazing project.
Thank you.
Great job.